Before we start, I would like to demonstrate how easy it is to generate a 3D model using FreeCAD. Let's quickly go and create a new file, and then I'll go in Part Workbench. Now, the thing that we are going to model is DN300 slip-on raised face flange with class 150. So all of the information for modeling of this flange is given in this screen that you can see right now. Now we'll start with basic flange OD of 485. So the radius is 242.5 millimeters. In FreeCAD, we can create a cylinder, and when you click on it, that gives you the radius, height and angle. Now the radius that we just saw was 242.5 millimeters and flange thickness is 32 millimeters. So I'll say 242.5 and 32 millimeters as the radius. Now when you enter those figures, you can see that the entire screen becomes blank. It's just that the original disc or cylinder that was placed in 3D modeling view was small, and it was the 3D model was able to accommodate it. But right now the cylinder is too big to be accommodated in the entire 3D model. So for that we will need to fit the entire content to the screen. So go to the left hand side and you can see, you can click on this button and it will fit the entire 3D model in the screen. Now I'll just quickly rotate it to see that yes, actually there is a disc which is the flange OD, has the radius of flange and the height of the flange. Next, what I would like to do is I would like to create the raised face and the hub. Now hub OD is 360 millimeters and hub thickness is 22 millimeters. So let's quickly do it. Model the hub. Now hub ID is 180 and hub thickness is 22. So 180 and 22. Now when you rotate this model, you will see that you can't actually see where is that cylinder, the new cylinder. But when you rotate it and when you see clearly, you can see that that cylinder is still there, but it is hidden inside of the original cylinder. So as we can see that cylinder 001 is hidden inside cylinder. What we need to do is we need to bring this cylinder 001 out in Z direction, as you can see from the trigon on the right hand side bottom corner of this 3D model. If we bring, or if we move, or if we shift this cylinder 001 by 22 millimeters, that is the height of this cylinder, in Z direction, we will be able to see this cylinder. Now this cylinder has to be moved in negative 22 millimeters to be seen clearly. So I will click negative 22 and definitely you can see that cylinder 001 is fully visible and it is out of cylinder. So this is the hub thickness. Next, we will need to create a cylinder which is for the raised face. So raised face OD is 400 or 200 millimeters in radius and the thickness is 2 millimeters. Now the other way of bringing this cylinder out of this cylinder, which is the original cylinder, is to make the thickness 2 millimeters more than the height of cylinder, which is the original cylinder for the flange. So we know that cylinder for the raised face needs to be 2 millimeter thick. Now the thickness of this original cylinder is 32 millimeters. So for this one, if I make this 34 millimeters, you can see that it is shown faintly out here. Now if we create the exact radius of it, which is 200, let's add 200, and you can see that we can see that cylinder out of cylinder 002 out of cylinder, original cylinder for the flange. Now what we need to do here is we need to combine them or make a union of these three cylinders. So the way in which we'll make the union is click on cylinder and press Ctrl on your keyboard and click cylinder 001. When you move your cursor on the top, you can see you can run boolean options like cut and union. Click on union and you can see that those two cylinders, cylinder and cylinder 001, have been moved inside Fusion, which is the new geometry for those two cylinders. We also need to include cylinder 002 to this Fusion, so we'll create union again. And now we only have one component in the 3D modeling space as well. Next, we need to create the center hole so that we can pass the pipe through it. That center hole can be done by the flange ID. Flange ID in our case is 325 millimeters, so it is 162.5 millimeter in radius. So going back to FreeCAD, create a new cylinder, 162.5 millimeters, and the height of this I'll just make it 100 millimeters. The reason for making it 100 millimeters is that we will be able to create sufficient enough long cylinder that we can fusion cut it. So not fusion it, but to cut it out of this. So we'll need to position this cylinder back by in z-axis by say minus 50 millimeters, and you can see that that cylinder is now cutting or passing through all the cylinders or passing through Fusion 001. When we are happy with it, we can click on Fusion 001, cylinder 003 by pressing Ctrl key, and then we'll click on make a cut of two shapes. When we click on it, we can see that we can now see the shape of a flange. Still, there are certain things missing from this. We need to create bolt holes in this geometry. So we know that the bolt hole diameter is 26 millimeters or 13 millimeter in radius. So let's first create a bolt hole. We will use cylinder to create it, and as we remember, the radius of bolt hole is 13 millimeters. So we'll create radius of 13 millimeters and height of 100 millimeters, so that we can, when we actually cut these, we can cut the entire thickness of the flange. The positioning of this will be again minus 50, so that we know that it will be able to cut through the entire flange thickness. Now placement of this is not correct. We need to place it at a bolt circle diameter of 432 millimeters or a radius of 216 millimeters. Number of bolts are 12. There are several ways in which we can accomplish this thing. The first way is to create individual cylinders like this and then position them so that they go in that location. To give you an idea of how this will work is, let's see the radius of the bolt circle. So bolt circle diameter is 432, radius is 216 millimeters. So if I move this cylinder 004 by 216 millimeters in Y direction, then it will be in position. Next, we can go in and create cylinders like this and move them to several positions. Now, the only problem with that is when we have to put them in X and Y positions here, they should be fine. But if we have to create 12 different bolt holes, it becomes a bit of a tedious task. To make life easy, what we can do is we can go to draft workbench. In that workbench, we go in and click on this polar array. In that array, what we need to do is we need to make sure that we have the array type as polar. I'll expand this. Now the number in polar we need is 12, and what draft workbench does is it automatically equidistant places each and every cylinder in its own location. So after we are done with that, we click on enter, and you can see in array you can only have one cylinder. You can see only one cylinder, but because we created that array, parametric modeling in FreeCAD helps us to generate this array. Going back to part, we can now use this array to cut 12 holes in the original cut flange. So I'll first select cut, next I'll click on control and click on array, and then I will go in and select make a cut of two shapes. When I do that, I can see that the entire flange is now built. This is exactly as what we wanted from this slip-on flange, which is DN300 class 150.